All right, so we're going to look at, I'm just going to review some of the points that we were discussing before. I just want to firstly just review this idea of interference. And so we have the situation that when two waves, or even more waves, doesn't have to be two, but when waves interact with each other, they interfere, and basically the wavelengths of the amplitudes, not the amplitudes, the displacement of the wave at that point, they add algebraically to form a new wave. So as I move the sensor up, you can see we're getting constructive interference there. They come over here, we're getting destructive interference. Remember what we said with this distance. When we're getting, let's start with constructive interference. When we get constructive interference, it means that the waves or the points from the both waves coming in are in phase. So they're actually adding together. So that's why we're getting a much bigger wave, an increase in the wave amplitude there. And this length from there and that length, if we look at that D1, D2, D1 minus D2 is actually equal to 0. They're an equal wavelength there, so they're coming in phase. Where if I move this down to a point where you can see that we are getting destructive interference, the wave is much smaller. This should actually just be a straight line. I haven't got that, but anyway, just assume that it is. So if I have that length and that length, this is D1 and D2, then D1 minus D2 is a half wavelength. So they're coming in exactly out of phase. The waves are coming in out of phase. We're having out of phase, and you're getting destructive interference at that point. Now, that relates to these two formulas. If I pull up my data booklet here, that relates to these two formulas here. I'll just pull them, get them in line. These two over here. So these two formulas over here are linked with your interference. And remember what the N stands for there. What does that N? It's a natural number here. N is a natural number, so it's 0, 1, 2, da 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 da. Okay, so this is the point where you're getting interference, constructive, destructive interference. Now, if I bring up, I think this is no, not that one. You bring up this one over here. Yeah. Actually, no, not that one. Now these PowerPoints which are on the site are actually quite useful, and just wanted to see if I've got something on destructive interference here. I don't seem to have for some reason. Maybe I've got any other one. What you do get though, let me just what you're getting when you get if you've got two waves, say I've got this wave over here like this, one wave, and that has got a value of A, and I've got another wave coming here at the same, and that's something like this, and that's got one of B. So my board's out of sync, so it's difficult for me to draw. But you're going to get a combined wave between the two, which is going to look something like this. It's going to combine. That height there will be A plus B. So what you get is you basically get a vector addition. You get a vector addition of the displacements. Of the displacements at that specific point. If this B over here if this B was in the other direction, say if you had something like this, you've got your one like that, and you've got your other doing this like that, and if that is A and that is B, then you're going to again have your vector addition of A plus B, but because the one will be positive, the one will be negative, it will actually lead to probably a graph that will look, a way that would look something like that between the two, a combination. So it's always a combination of the two that you get. All right, so that's the idea behind interference. Are you okay with that? Makes some sense, eh? Okay. Okay. Now, we also looked at this idea of diffraction, which is the bending of waves around a barrier, and that was just caused. Let's bring this in here. Have one slit, and let's have one drip here, and let's remove this over here. So you got a bending that takes place. If I make this slit width quite wide, you're getting a bending around the barrier that's taking place. This is this idea of diffraction, and basically the idea behind it is that a wave over here in the center, you'll be having your wave fronts that will be going like that, but on this side over here, by Huygens principle, each point on the wave is a new source of a wave. These points over here are making new waves, but they haven't got points on to the side of it to cancel them out. So these form like circular waves that go out like it. Where these ones over here, these have got points on either side, which cancel out the sideway movement and just lead to the wave fronts going out. Okay, so you don't need to go into too much detail about that, but you need to understand what diffraction is, the bending of waves around a barrier, some sort of barrier. Yeah. Superposition of waves is what I was just talking about, that when you get two waves on top, you'd have a vector addition of the displacements. You've got to be careful. So say if you've got one wave, say if I had one wave like this, and I've got another wave that's coming in, say this wave is going in this direction, and I've got another wave coming in this direction, and it's something like that. Now, if I take this point, that point over there, you can see where I am here. Now, it'll be the vector addition of those two displacements, of the green and the blue wave. And so for the new wave, it would be like double that size there. It would be over there. You see, it would be that length, and the other length over there. It would be those two lengths there that it would be. All right, that forms that big one over there. Okay, so that's a superposition. That's an adding up at those 2 points. Yeah.
So would the wave be just like this, or would it be like more gradual?
Well, you see, what would actually happen here is that you'd get a new wave forming that over there would be slightly increased. I wish my board was in sync to be able to draw this, but you'd get something like this. So you'd get a wave like this being formed. Okay. And then as the two come together, that will expand to make one wave, and then it would separate again from each other. Okay.